Finding logarithm of numbers between 0 and 1, we shall first have to express these numbers in standard form, just like the way we did with the numbers above 10. So here's an example. These are very many of them. We shall do some, and the others will be assignments. Like I said, when you have the video, you can pause and copy the work and try it out, transfer it to your books. So the logarithm of these numbers can be obtained by first expressing the numbers in standard form. Somebody is saying, should you take note summary? Yes, you can summarize. That's why I advise you to have notebooks around you, have a calculator. You can summarize this work here. As I'm explaining, you can note down a few things while listening. So that's what we're saying. Find the logarithm of 0.44. How do you find that logarithm? Let's have it as an example here. How do you find the logarithm of 0.44? We said this has to be first expressed in standard form. So we need to express this in standard form before we can do anything. So 0.44. What is 0.44 in standard form? And what would this 0.44 be like in standard form? Is equivalent to? And I can't hear you. Yes, Prosper.
4.4 times 10 to the power -1.
4.4 times 10 to the power -1. That is 0.44 in standard form. So you notice that this 4.4 is between 1 and 10. So you can get this, the logarithm of this from our mathematical tables. So this 4.4, what's the log of 4.4 from our table? How do we find it? Can somebody tell us how we find this? We did this last time. Can somebody look at this table and you tell us, let somebody look at this and it tells us that the logarithm of 4.4. What's the logarithm of 4.4? We learned how to do this last time. What's the log of 4.4? Yes, Martin.
Teacher, you first go to the first column of the table. You locate where you locate where 4 is.
Where 4 is?
On the where 4 is. Then you come to the 0. You look for where 4 is.
Yes.
Then you go to the column that has 4.
Our value, the log we're looking for is log of 4.4. So we said the column headed X gives us the first 2 digits, and our first 2 digits are 4.4. There is 4 and 4. So you come to the first column headed X. This is the column headed X. Hope you're seeing my table. This X is here, but it's not very clear. This is a column headed X. I come here, move downwards until I find 4.4. 4.4 is here. Now, then I look for my next digit. What's the next digit on this? It is not there. So we assume the next digit is 0. You see that? The next digit is 0. So then I move in the first column. Where is 0? 0 is here. I also move downwards till where I find where the 2 coincide. The first 4.4 and where this 0 coincides with the 4.4. So I move downwards like this. Where do they coincide? I still move, continue. I've not reached where 4.4 is. I continue moving up to this point. You notice that a line from here, they're meeting on this where they're intersecting, 0.6435. 0.6435. That's what we have. That means that the log of 4.4 is 0.6435. I remember I even taught you how you can find this value using a calculator. But sometimes in exam they say without using a calculator. Or they can say use mathematical tables. So if they say use mathematical tables and for you use a calculator, then you'll have not respected the instructions and you'll be penalized for that. They will know there's always a slight difference between the value you get from a calculator and the one you get from the math table. This one in a calculator, you may find this. You notice that all values from the math tables are to 4 decimal places. You can see all of them. Hello, can you mute yourself, please? Mute yourself. So you notice that all the values you're getting from the mathematical tables are to 4 decimal places. Now, for you to use your calculator and write them to 2 DPs. And somebody just know this one, never use the mathematical table because there's no way you get 3 DPs from a mathematical table. It always gives 4 DPs, 4 decimal places. Or you may write 5 decimal places. The tables always give 4 decimal places. So let's always respect that. When they say use mathematical tables, even when you make exams, ask for the mathematical tables and they'll give you that you're entitled to these books. Whenever you're going for any math exam, they have to give you these mathematical tables. But of course, they have not been giving you since you had not covered this work that requires the use of mathematical tables. Or you buy your own, buy your own and they will allow you to use it. Then also don't, of course, misuse it. Some of you try to write answers or formula in it. So you note down a few things as I'm explaining, you can keep noting down. Then this is what we have. But then remember, at the beginning we said, if I write log of 4.4 to base 10 is equivalent to 0.6435. Here, I'm simply saying that if I have 10 to the power of this, it has to be the same as 4.4. You recall our definition of logarithms. So here I can simply say 4.40 is equivalent to 10 to the power of 0.6435. That's what we're saying. And that's how we define our logarithms. We say that if I have log of 4.4 base 10 equals to 0.6435, I'm simply saying if I raise 10 to the power of this, must give me 4.4. So that means that my 4.40 is equivalent to this. Now I'm going to come to this, what I've written here, this one here. I remove the 4.4 and replace it with this. So you end up with 0.44 being equivalent to, where there is 4.4, I'm putting this to be 10 to the power of 0.6435, then times 10 to the power of -1. You notice that? Do you see this? Where there is 4.4, I'm putting its equivalent, which is this one here. Martin, is that okay? Martin?
Yes, teacher.
Okay. So at this point, we can now...
Yes, teacher, thank you.
You're welcome. So at this point, we studied about learned indices. We did something about indices and we said, if the bases are the same, then you must add the powers. If the bases are the same, then you should add the powers. But now in logarithm here, I'm going to introduce something that we've not seen before. When you have something like this, notice that this is -1 and this is 0.643. So how do we write this? We may not add, because when I add this, it gives me something like, to give me something funny. So what we do, we leave this -1 alone and also write this one alone, and this will give us, this will be the same as 10 to the power of this 1, we are going to put its negative on top. This will be 1, and this is 1 bar. Or you can call it bar 1. It's because it is negative, so I'm attaching this negative on top. Then 0.6435. That's how we write it. This step here is where you have to pay attention. We have 0.44. We said if you write this in standard form to be the same as 4.44 times 10 power negative 1. I went ahead and looked for the equivalence of 4.4 in index form, and I found this 10 to the power of 0.6435. Now, where there is 4.4, I removed it and put its equivalence, which is this one here. Then here I'm applying the laws of indices where I'm supposed to be adding the powers, but since this one's negative and this one's positive, I'm not combining them. I simply write it as this 1 bar, and then this one also comes after with its points. So 1 bar 0.6435. So that means that here, that means that 0.44 is equivalent to 10 bar 1.6435, like that. Which this is now in index form. But if I write it in logarithm form, I'll say the logarithm of 0.44 to base 10 is equivalent to 1 bar 0.6435. So this is the logarithm I was looking for. And that's what we do. When you have numbers between 0 and 1, that's how you get the logarithm. Any questions so far? Can I have some questions before we proceed? Have we all understood? Yes, please.
I've understood.
You've understood, eh? Okay, if you've understood, let's now do another example. Let's do another example.
I was meaning me. There was another person who had a question.
Yes, who else has a question? Please feel free to ask, because that's when you understand the things.
If you don't set the powers, what do you do?
If you don't have?
If you don't join the powers, then what do you do with them?
If you don't add the powers, you're breaking. Yeah, I can't get you clearly. I don't. Who has understood this question? Maybe if you can help somebody with better network. What is he trying to say?
What do you do with the powers?
What do you do with the powers at this point? We just combine them. This is -1. This is 0.6. This is -1. This is 0.6435. So we combine them, put the negative on top, then bring the other decimal, which is 6435. And that's what we have. We just combine them like that. You have the negative on top, then the other. If this was -2, I would have written 2 bar, then point. This other one will always be fraction, it will always be a decimal. There will always be a 0 here. So it is 1 bar. If it was a positive, I would have said 2 bar, like that. You notice even in the other cases we're doing, the other numbers we did for the numbers above 10, it was supposed we just had 2.3 point. Now even here we leave the negative, don't add them, just write them in this form. Write them in that form where you just attach the bar on top of the negative, then point the other part. This part is positive. Remember, this one is negative, this one is positive. We don't want to mix them up. That's why we combine them like this. But we know this is -1 and this is positive 0.6435. So let's do another example to enable you visualize this maybe more. Allow me to shift this table a bit because it is mixing up with our work. Let me put the table here. We shall keep referring to it, the logarithm table. Okay, so let's move on now. I will also delete this. I hit the rubber. Okay, let's go to number 2. I'll delete those ones later. Number 2, 0.9. Find the logarithm of 0.9. Now 0.9 is below 1. You know, it is between 0 and 1. So what do I do? If I have 0.9, I'll first have to write this in standard form. 0.9 is equivalent to, can somebody tell me 0.9 in standard form, what would be like?
9.0 times 10 to the power negative 9 times 9 times 10 to the power negative 1.
9 times 10
over to power negative 1.
Power negative 1, like that. So that's what we have. Then I go ahead and look for the log of 9. At least my table gives me the logarithm of numbers between 10 and 1. So this 9 is between 10 and 1. I can now go and look for its logarithm from the table. So I'll say, what's the logarithm of 9? Of course, I'm not putting any base because it's automatically base 10. So I come to my table. What is the logarithm of 9? I look in this column. Remember, I said this one gives you the first 2 digits, then the 3rd digit, then the 4th digit is where we say add. Now this 9 is the same as 9.000. My first 2 digits are 9.0. I come to the first column and look for 9.0. We learned this the other time, how to find logarithm of those numbers. So what is the logarithm of 9.0? First column gives me the first 2 digits. First column has to give me the first 2 digits, so I'll come here and look for the for 9.0. This one stops at 5.4. I go to the next table. Let me also shift it here so that we can. I want to shift this table, click here and then click on it, carry it to this point. So 9.0 is here. Hope you're seeing it. 9.0 is somewhere here, down this way. 9.0 is here. Those are my first 2 digits. What's the 3rd digit? The 3rd digit is also 0 because it says it is 9.00. So the 3rd digit is 0. I come up here where 0 is here. So I move downwards up to where I'll find where the 2 are coinciding. It will be this point. So it will be 0.9542. Then the other digit is 0. I come up. Is there any other digit? No, there's no 0 here. It starts with 1. So that's what my logarithm will be. 0.9542. The logarithm of 9 is 0.9542. So I can write it up here. My logarithm of 9 is 0.9542. That's the logarithm. Now, we all know that, of course, there's a silent base 10 here. That means that my 9.000 is equivalent to 10 to the power of 0.9542, like that. Somebody has a question, Desmond?
Can you please help me on how we use that upper side on the logarithm table?
Yeah, this upper side here. The row. This is what we learned the other time. Okay.
Yes, the upper row.
Okay. Let me show you here. If I'm looking for the logarithm of, let's say, 1.436, I'm looking for that logarithm. Now, these first 2 digits, these ones here, are obtained from the first column. The first column, this is what we call the one-headed X, having X on it, on top of it. That would be the first. Then this other one, the third digit, is obtained from the first row. First row. That's the third digit. Then this last one, the fourth digit, is obtained from the section of add. You know, add, of course, also in the first row. First row. That's why you get this. So I look for where 1.4 is. Let's now do it together. We get this together. I look for where 1.4 is. Where is 1.4? In the first, of course, I was saying the first two digits are obtained from the column headed X. This is my column, column headed X. 1.4 is here. Are you all seeing it? Is that yes. Okay? Then I'm done with my first, I've used my first two digits. Then I go to the third digit. Third digit yes, is 3. And we're saying we get this from the first row. This is a row, of course, you must be knowing what rows and columns are. This is the first row. So where is 3? 3 is here. Now I look for the point of coincidence where there's 1.4 and 3 coincide. That will be down. I move this one down. I also move horizontally. Notice that they're coinciding on this value. That's why they're coinciding. Remember, there is a point. Points have been indicated in the column headed X, headed 0. Here there are no points, but all these values you see have decimal points before them. So where are they coinciding? They're coinciding on 1, 5, 3, 5, 5, 3. That's why they're coinciding. So after that, I move on. What's the other digit? The other digit is 6. Where is 6? We get 6 from the section of add. 6 is here in the section of adding. Some tables have subtract, but of course the ones you're going to use even in exams will have this section having add. So that means that you add whatever you see this way on top on what you've gotten before. So this is my 6. I also move downwards. Where does it coincide with this? It coincides on 18. That's where they're coinciding. So I come and add. That's what that section says, add. I add 18 on this. That gives me, this is 1, this is 7, this is 5, this is 1. So 1571, like that. So that means that the logarithm of 1.436 to base 10 is the same as 0.1571. Is that clear now?
Yes, teacher.
Yes, thank you, sir.
Yeah, thanks for asking. You always have to keep asking in case something is not clear, so that we move together. So that is okay now. Let's now move on. So some numbers, when they give you a number like, let's say 1.4, you don't have the third digit, you don't have the fourth digit. That means that the third digit will be 0. You see that the others will be 0 zeros. Then you do that. If they just give me 1, they want me to find the logarithm of 1. That means that the other digits are all zeros. You see that? That's what it implies. That's what we're doing with the 9. For 9, we have only 1 digit. The second digit is not there. The third digit is not there. Yet for us to find the logarithm, we need at least 3 digits. So we assume the other digits are zeros. Then you come and look for the logarithm there. Okay. So let's go back to our work. I've found the logarithm of 10 as 0.9542. Logarithm of 9 as 0.9542. That's the logarithm of 9. But from the definition of logarithm, I remember explaining and saying that if they say logarithm of 9 to base 10 is this, they're simply saying 10 to the power of this is the same as 9. And that's what I've written here. So where we have 9 here, we're going to remove it and put this one here, the equivalent. So that means that my 0.9 is equivalent to, where there is 9, I'm removing it. It is now 10 to the power of 0.9542 times 10 to the power negative 1. Now from the indices we learned earlier, we're supposed to, the law says if the bases are the same, and in this case you can see that the bases are the same, it is base 10, base 10, base 10. you're supposed to add the powers. But here in logarithm, we're also saying adding them brings a lot of confusion. What we're going to do, we shall simply combine them, but just attach a negative on top of the negative one. Just attach a bar on top of the negative one. So we shall have this, the logarithm 0.9 will be equivalent to 10, the same base. Now, instead of adding, of course, while adding this, if you use your calculator to add and get something very funny. So we maintain them, but combine them, but just attach a bar on this 0.9542. That's what we have. So if I write this in logarithm form, this is in index form. Logarithm form, that means the log of 0.9 to base 10 is the same as 1 bar or bar 1.9542. Chimera, you have a hand up.
Teacher, I'm not understood.
Which area exactly?
Combining, instead of adding, combining the negative one.
Okay. So I'll take you to a simple view here. When you're looking for the log of logarithm of 15, what did we do when you're finding logarithm of 15? We said the logarithm of 15, you first write 15 in standard form. This will be the same as 1.5 times 10, the power of 1. Then I come here and look for the logarithm of 15. That will be 1.5. The first two digits are here. 1.5 is here, and then the next one is not there, so it is 0. I take, this is 0.7. Logarithm of 1.5 is 0.1761, like that. That means that my 1.5 is equivalent to 10 to the power of 0.1761. But remember, we're not looking for the logarithm of 1.5, we're looking for the logarithm of 15. So my 15 is equivalent to, we said, 1.5 times 10 to the power 1. So this will be 1.5 is equivalent to that. That will be 10 to the power of 0.1761 times 10 to the power 1. So when you add this, when you add the powers, this becomes 10 to the power of 1.1761. You notice that this one here, the one just came here. This was for the positive values. The one just comes here. So even here for the negative ones, we don't combine them by actual adding the arithmetics that we use for adding numbers. We just bring them together but attach a negative on top. Because if you add this, you're going to find something weird. It will be negative something, you know? It will be, yes. And that in logarithm we're saying, don't add them, just leave it like that, but attach a bar to show that one of them is coming from -1. Because later on you're going to have other manipulations, adding, subtracting, dividing. So if you combine them, it becomes a bit confusing in logarithms. So what we do is we leave it as bar 1 point. I just bring the other one. You notice that this is -1. This -1. So I simply say bar 1, then bring these other digits. Yes, please. Somebody has a question?
Yes, I was asking.
Yes, please.
What if when you put the number in standard form and it gives you let's say 10 to the power,
you can't say
10 to the positive, or let's say it's not -1. There when you're putting it, or when you're putting the powers, you put a bar or you don't.
Sorry, you're breaking. You're saying, please.
Let's say when you put the number in and the power you get is not a negative, do you put a bar at the end when you're putting the logarithm?
Do you put what?
Oh, the power.
You're breaking, please. What you can do, maybe you can go to chat and type. Go to chat and type. Let me have Wamboka. I think Wamboka has a hand up. I have not gotten your question well. Maybe you can type it in chat. I'll get it there and maybe respond to it. You're breaking. Your network is not stable. Somebody, Wamboka also has a hand up. Yeah, ask, because we're going to use this very often in all the other applications. We shall be using this concept. So I want to make sure we move together. I want to make sure we move together. Kimera, sorry, I didn't get your question well, but you can, if you get a place with better network, you can ask again and we'll go through it. Or you go and type it, I'll get it there and we'll answer it. Okay, I think let's move on. Maybe some of the questions will be answered as we do more examples. So at this point, I've found the logarithm of 0.9, and is the same as 1 bar 0.9542. That's how we write it. Or bar 1 0.9542. Let's now move on to another one. The other one is 0.005. 0.0005. How do you find the logarithm of that? Let me delete this also. It is affecting the working space. Now I'm looking for the logarithm of 0.005. So what I first have expressed this in standard form, write this in standard form. So I'll have 0.005 is equivalent to, can somebody tell me this in standard form, what it be like?
5 times 3 to the power negative 3. 5 times 10 to the power negative 3.
Power negative 3, like that.
5 times 10 to the power negative 3.
Okay, I finally get your question, Chimera. You're saying that if you write it in standard form and the power is positive, do you still attach a bar on top? No, we don't. We did that by the before when you look at logarithm of numbers above 10. You don't put a bar on top if it is positive. I've just done it somewhere here. Look at this. Logarithm of 15. This is a positive number. It's a number above 10. So what did we do? We express it in standard form and we have this. Notice that the power of 10 is positive 1. Please mute yourself if you have noise in the background. So we shall have this. This one is positive. So when I come to this stage, what's the logarithm of 1.5? I get this. When I'm combining them, I've not put a bar on top of 1 because it's positive. This one is negative. That's why you're putting a bar on it to show that, yes, this is a negative, but the negative is only for 1. It's not for the whole thing. This is positive, but this is negative. The 1 is negative. Okay, let's do this one maybe to make us also visualize that more. I have my 0.005 in standard form, the same as 5 times 10 to the power negative 3. Then I look for the log of 0.5. We do this because our tables can only give us logarithm of numbers between 1 and 10.
9.
Between 1 and 10. So a number like 0.005 is outside that range. So expressing it in standard form brings it in the range that we want. You notice that now 5 is within the range. We can now find the logarithm of 5. So if we have 5, what's the logarithm of 5? The logarithm of 5, of course, this is to base 10, will be what? I go to my table. This 5, you notice that there are no other digits, so it's the same as 5.000. So my first digit, the first 2 digits I'm looking for are 5.0. I'll come here and look for 5.0. 5.0 is here. 5.0 is here. Now the next digit will be 0 also. Next digit will be 0, and of course the first digit here is In the second column, this is also 0. So I move downwards till when they coincide from here. The other one is 0. I go the section of add. When you go the section of adding, there is no 0. It starts, adding starts from 1, so there's nothing to add. I just go here and I take the logarithm, which is now 0.6. The logarithm of 5 is 0.6990. 0.6990. So this will be 0.6990. But in the question, 0.699, okay, is 0.6990. In the question, they're not asking me to find logarithm of 5. No, they're asking me to find logarithm of 0.005. So where there is 5, I'm going to substitute this. Remember, here we're simply saying 5 is equivalent to 10 to the power of 0.6990. So where there is 5, I'm going to substitute this. So we shall have, this becomes, create more space. This becomes, it becomes 0.005 will be equivalent to, where there is 5, I'm going to substitute all of this. The equivalent, you know, the equivalent value, which is 10 the power of 0.6690. That's what we have. Times 10 to the power of -3. That's what we have. So then we say this is the same as 10. The 3 is negative, so I write 3 bar 0.6690. That is the equivalent of 0.005. So at this point,
66990.
Sorry? Yeah, it is 99, sorry. I don't know why I'm writing 6699. Thanks for that observation. So at this point, we shall say, the space is not enough. We shall say, of course, when you write this in logarithm form, we shall simply say the logarithm of 0.005 to base 10 is equivalent to 3 bar or bar 3.6990. That's how we find the answer. Is that clear now?
Yes, teacher.
Okay. So
Yes, teacher.
let me do, which other one should I do among these ones so that we don't do everything? We've now learned what to do. We can now just do one more if somebody
0.00046.
Which number is it?
Number 5.
Number 5. So let's do number 5. You can also identify the one you want us to do and we'll do it. Number 5. So the other that I'm going to leave out, as you're copying the work, in fact, as you're noting down, of course, you're supposed to be noting down. As you're noting down the work, you note down these ones, you work them out on your own, and you feel free to submit them to me and I go through. So we have 0 point, how many zeros are these? 4. 2, 3, 4, 4, 6. This in standard form is the same as, can somebody tell us what is this?
4.6
4.6 times 10 to the power
times 10 to the power -5.
Times 10 to the power -5. That's what we have. So then I go and look for the logarithm of 4.6 from the table. The first 2 digits, 4.6, they are here. What's the next digit? It is not there. So what do? We take the one of 0, which is this other one here, which is 0.6628. That means that the logarithm of 4.6 to base 10 is equivalent to 0.6628. That means that my 4.6 is equivalent to 10 to the power of 0.6628. Now what I'll do next is, where there is 4.6, I'm going to substitute. I just carry the whole of this one here and put it here, where there is 4.6. That means my 0.12346 will be equivalent to 10 to the power of 0.6628 times 10 to the power of -5. So this becomes my 0.12346 will be equivalent to 10 to the power of, this will be now 5 bar 0.6628. 6628. So that means that my logarithm, the logarithm of 0.000046 to base 10 will be equivalent to 5 bar 0.6628. That's what we do. That's what we do there. So I think you can now do the rest. Is there anybody who still have, if you're still having challenges with this work, feel free to ask, and we do them. This number 9 here, I think it is, I was supposed to put 0.4 something, but I mistakenly put this one here. It's supposed to be 0 point.
Also number 12.
Number 12.
Okay, it's above 1.
Yes, it's above 1. That's also a mistake. It's supposed to be 0 point. Like that. Even this one. Number 13, 0 point. Number 5.
Number 15.
Number 12. This one here. But we have enough numbers. I can even delete this. Remove it. I can also delete this one. The numbers we have are just enough for us to practice. Those ones will be enough for you to practice. Any questions from here before we go on? Do you have any questions from this section before we move on? Okay, let's do one more. Let's do one more. Let's do number 11.
Number 8.
Number 8, okay. Number 8. Number 8, what does it say? They want to find the logarithm of 0.0102. So here the first thing I'll do is I express this in standard form. 0.0102 in standard form to be equivalent to Philip.
1.02 times 10 to the power -2.
It will be
1.02 times 10 to the power -2.
1.02 times 10 power -2. Power -2. So we can leave out this 0 here. This other 0. No, we can leave out this first 0. There's no problem if we left it out. And we write just like that. This is the same thing. No? 0, it will be 1. We just shift the decimal point 1 place, 2 places. So it will be 1.02 times 10 power -2. Since we moved 2 steps into the right direction, that's what it becomes. So we have something like this. And then what will be the logarithm of this? Log of 1.02. Log of 1.02. What will it be equivalent to? That will be equivalent to what? We come to our table. My first 2 digits are 1.0. My first 2 digits are 1.0. 1.0 is here. What will be the next digit? Next digit is 2. 2 is this. So it gives me 0.0086. It gives me 0.0086. So I'll come here and say 0.0086. That's what we have. So we are going to start at That's it. So from here we shall have like that. So from here
Let's say look at so
Solo.
Ivan, wait.
So from here, we have the equivalence of 1.02. Where there is 1.02, we substitute. We substitute it here. So we shall have 0.0102 being equivalent to 10 to the power 0.0086 times 10 power negative 2. So this gives us 10 to bar point 0. I mean 0, not 0.0086, just like that. So just combine them. Just have 2 bar like that. Is that okay? Now the other thing maybe I need to show you is you can use a table. I've not shown you, given you that approach of using a table. Let me show you here. Instead of having all these, you can just have a table and summarize everything in a table, like we did with the other logarithms. Let me do number 9 using a table. Insert, I can put a table with 3 columns. So our table will be having, this is the table. So in this table, you'll be having the number. Then you have standard form. The next column will be having standard form. Then the other last section you have logarithm. So let me, what's the number we're dealing with? The number we have is 0.42. Then standard form, this in standard form will be the same as what? We know it will be the same as
4.2 times 10 to the power negative
4.2 times 10 the power of negative 1, like that. So when it comes to the section of logarithm, I just write my 1 bar. Because this is negative 1, I simply write it there, 1 bar point. Then I go and look for the logarithm of 4.2 from my table. What's the logarithm of 4.2? I look for the logarithm of 4.2. 4.2 will be here, which is 0.6, which is 0.6232. 6232. So I just come here and write 6232 like that. And I've finished. That's how we use the table. I want to carry this table around. Let me see if I can. The table can't be carried. Okay, let's just leave it there. Okay, I can shift it like that. Okay, these ones have again remained. So here we said you simply put the number in standard form, which will be 4.2 times 10 power negative 1. Then here you just put 1 bar point, what you get as a logarithm 6232, and you'll have finished instead of going through all this process. That's also acceptable. That's also acceptable. We can do it like that. The same applies to this other one, 0.88. 0.88, we can also do it in the same way. This is now the second method that I can use. Instead of writing 10, I just wanted to show you what is going on before I take you to the table. So in the table, I again insert my table with 3 columns and 2 rows. This is what I have. I can carry it up a bit. This is 8. So I expand this, expand this one. Now, the first column, I have the number. Not here. It's in the first column. First column, I have the number. Second column, I have standard form. Standard form. Then in the last one, logarithm. Now, what's the number we're dealing with? The number is 0.000. How many zeros are those? Some of those good eyes, you tell us. Are they 6?
6.
They are 6.
Yeah, those are 3, 4, 5, 6, 8. Then standard form. Can somebody tell us what it will be like in standard form? Standard form
8 times 10.
8 times 10 to the power negative 6.
8 times 10 to the power of negative 6.
7.
7, yes, it is 7. Power negative 7. So here I'll have 7 bar. 7 bar. Point. What will be the logarithm of 8? I come here and look for the logarithm of 8. Remember the other, if it's just 8, that means the other digits are 0 zeros. So I'll have 8.0, then 0. It gives me 0.9031. 9031, like that, and you are finished. So this approach is also acceptable. You can use it. In fact, it's the one day people use most. You'll find in most of the textbooks. I was using the first one just to make you understand what is really taking place, you know, what is really going on. Any questions? Somebody is saying we do another example on that. Should we do another one?
Yes.
Okay, let's do number 11.
Number 13.
Number 13. Let's do number 11. Number 11, we're still using the table approach, but we can also do it using the other approach that we learned. I insert the table. Of course, for you, you'll be drawing it. You draw your table. Your table must be having 3 columns, like this. I can expand them like that. Then like this. Now, what do I have? I have the number in the first column. Number, wait, or is it going in the second column? Number is here. Then second column, I have standard form. Standard form, that the spelling, standard form. Then lastly, I have the logarithm, but this table is again too long. Logarithm, like that. So I can make this table shorter by pulling it this way. Okay, so that's what we have. What's our number? The number we're dealing with is this one here. It is 0. The number I'm dealing with is 0. Let me pick the pen. 0.0020059. That's what I have. What will this number be like in standard form?
2.059 times 10 to the power negative 3.
2.059 times 10 to the power of negative
3.
Negative 3. Yes, negative 3 because I'm moving the decimal point from here 1, 2, 3 steps to the right. So this becomes 3 bar. Because it is negative 3, it will be 3 bar. If it's a positive one, you just write 3. If it's a negative one, it's 3 bar. Point. What's the logarithm of 2.059? First 2 digits, first column. 5, I get it in the first row. 9, I get in the add section. This is a long one this time. So where is 2.0? I look for where 2.0 is in the first column. 2.0 is here. What is the third digit? Third digit is 5. 5, where is 5? 5 is here. So where are they coinciding? This point, 311. 3118, that's what I have. But that's not the last, since I have another digit. 3118, I write it there. What's the other digit? 9. 9, I go to the add section. This is the fourth digit. Where is add? Add is here, 9 is here. Not add is there, 9. 9 is here. It is coinciding with 19. If you can use your eyes very well, 9 is here. They are coinciding at this point 19. So I first add before I introduce the decimal. I come here and add 19. Is it 19? Was it 19? No, I've forgotten.
It was 19.
Yeah, 19. 19. So we add. This gives me 7. I carry 1. This gives me 3. This gives me 1. This gives me 3. So that means that is the same as 0.3137. I leave out the 0, just carry the 3137. That's what I get as the logarithm of. That's the logarithm of 0.002059. That's what you do using a table. So which one do you prefer of the two approaches?
Table.
The table.
Table.
Yeah, it's okay now. You can use the table. But you now realize that the first one helps us to understand the table. You can now visualize. You can know what we're doing. But if you had gone the table straightforward, then you end up cramming what you don't understand. But the other approach shows you why now we're writing this. We're supposed to add somewhere, so that's why we write 3 bar point. Now let's move on. We have some few minutes left. Let's move on to the next concept. If you don't have questions, of course. But if you do, you can ask. If you do have questions, you can ask. If you don't have, we'll move on. The next concept we want to look at is the ant logarithms. There's a concept called logarithms.
So may I go back to the exercise?
Sorry?
May
I? Joshua Wachemba, your hand is up.
May you go back to the exercise?
Yes.
Teacher, how do you do it when there are like 4 digits after the decimal point to find the logarithm? I haven't got it very well, like the add and the second number.
If there are 4, this one of 2.059. We say the first 2 digits are obtained. The first 2 digits are obtained from the first column. The first 2 digits are obtained from the first column. So I go to the first column, which the one headed X. We're looking for the log of 2.059. These first 2 are obtained from the column headed X, the first column. Then this 5 is obtained from the first row. Then this 9 is obtained from the section of add, like that. So 2.0, we have 2.0. 2.0 is here. That's our 2.0. You're seeing it? Hello?
Teacher, I'm seeing.
You see the 2.0. Then the next digit is, what's the next digit? Next digit is 5.
5.
So I come to the first row. Where is 5? 5 is here, you know? So I look for the point of coincidence, whether the 2.0 and 5 coincide, you know? They are coinciding here at 3118. 3118, so already 3118 is here. This is my 3118. But I have another digit. I have another digit too, which is 9. So I go the section of add. It is the fourth digit. I go the section of add. Which section has add? If I can scroll this side. 9. 9 is here. So I again move down and look for the point of coincidence where they coinciding. They coincide at 19. You seeing the 19?
Yes.
So I go and add the 19 on my first value that I got. Which value did I get? I got 3118 plus 19. I get, it gives me this, and I introduce a decimal point because all the values here, you see that the first column, there are decimal points before it. So after getting this, you must put a decimal point there. So the logarithm of 2.059 is the same as 0.3137. Is it okay now?
Yes, teacher.
Okay, that's good. Yeah, you feel free to ask, please. Don't, because you're going to find this logarithm everywhere. You go to senior 4, you'll find logarithm. Senior 5, you'll find logarithm. Even go to university, if you're doing a math-related course, you'll find logarithm there. So we need to understand the thing thoroughly. So the next concept that I want to introduce in the next, we're going to look at it in the next 5 to 6 minutes. Then next time we build on it is ant logarithm. The opposite of logarithm is ant logarithm. When they give you the logarithm, they can give you a logarithm and ask you to find a number whose logarithm it is. You see? They give you a logarithm and ask you to find the number whose logarithm it is. So that's what I want to introduce here basically. Then we shall build on it in the next lesson. So ant logarithm also has its own table. This is the table for ant logarithm. Logarithm have their own tables, and logarithm also have their own tables. So let me shift this so that the tables don't mix up with my work. A moment as I try to set up the work. It's not moving. It's okay. And logarithm, we're saying the logarithm of a number 2.4. If they ask to find the logarithm of a number, the logarithm of a number 2.4 is given by this. If you look for the logarithm of 2.4, it will be that. The number whose logarithm is 0.3802 is called ant logarithm. You know, it's the opposite. Ant, I think you know from your English, you know that ant means the opposite, you know. It is ant something, it is antagonizing it, it is in the opposite, it is the opposite of the other. So just like we've been finding, just like we've been finding the logarithm, they can also ask you to find the ant logarithm. And this used the spaces to my, okay, let me just start from here and we continue. The logarithm of 2.4 is 0.302. The number whose logarithm is 0.3002 is called the ant logarithm, which is 2.4. Thus, ant logarithm of 0.302 is 2.4. So how do you find the ant logarithm? There's an example here. I am just going to show you like 2 examples and end the lesson. Ant logarithm of this is 0.2. So we've been finding, let me just take you back to the numbers we've been doing. We're saying the logarithm of 2.059 is 0.3137. Now, what is the ant logarithm of 0.3137? It will be the same as 2.052. The logarithm is this, the ant logarithm is in the reverse direction. So let's try out this number. Now, what they have given us here are logarithms. Find the numbers whose logarithms are. So they have given us the logarithms here. They want us to find their numbers. Which number has a logarithm of this? That's what they want you to do. You have a number, they want you to find its logarithm. Let me start with an obvious number, the one we know, as an illustration here, before we go to these examples. Let's say you have, we are saying, we say that logarithm, if you're finding logarithm of 10, base 10 is 1. Now, in this case, they will simply say find log of maybe x base 10 is 1. They're asking you to find the value of what is this x here. What value has a logarithm of 1 to base 10? What value has a logarithm of 1? So in this case, we know very well that this is the same as x equals to 10 to power 1. Then you look for this value of x. That means that x will be 10 in this case. Now, even here, they're asking you to find they're asking you to find the number whose logarithm is this. If you say, let that number be x, we don't know it. We don't know the number whose logarithm is that. Let the number be x. Let the number be x. Of course, here we're working in base 10 always. So that means that we shall have logarithm of the number. We don't know the number to base 10 has to be the same as 0.6841. That means that my x will be the same as 10 the power of 0.641. I need to find this number now. What number is it that has a logarithm of that? So there's a table that you can use, which is called the table of ant-logarithms. But you can also use your calculator. Just go to your calculator, press 10, the symbol of power, that symbol there, it is some inverted V if you have an original calculator. Then 0.64, 0.6, there is an 8 here, 0.6841. What do you get? 0.6841. What does it give you for those with calculators? What do you get? Anyone with a calculator? Yes, Joseph?
4.8.
You get 1 point? 1.8?
4.8.
Can you give me 4 DPs? Is it exactly 4.8 or there are other values? Give me to 3 decimal places. 4.8?
4.832.
4.832.
Now, let's see how we can find this from our table. Can we find this from the table in any way? Let's go to the table of ant logarithm. The same way we did with the logarithms. The first 2 digits. I'm looking for 0.68. So the first 2 digits have to be obtained from the first column, 0.68. You got the table of ant logarithms, you got the table of logarithms. This time we have the logarithm, we're looking for the number. So we got the table of ant logarithms. This is my table of ant logarithms. So I look for where 0.68 is. Where is 0.68? 0.68. 0.68 is here. This is my 0.68. Then what's the next digit? The next digit is 4. I go to where 4 is. 4 is here. This is my 4. This is the 4. They are coinciding at that point. So what I've seen so far is 4.831. What does the other digit say? We have 1 at the end. 1 at the end, and the 1 says add. There is 1. There is 1 here. This 1. So this 1 I add it to the last value. I add 1 to this.
Some of your screen is
Plus 1, but this one I added to the last digit is just like adding 0.001. So this becomes 4.832. That's what I've seen as the ant logarithm. You see that? What did you get? You got 4.832, and that's what I've also got. You see that? So that's how we find ant logarithm. The way we find logarithms, you look for the first 2 digits. First 2 digits in the first column. The first 2 digits are 0.68. So I look for 0.68 here. Then the next digit, I get it from there. Then I go to the add section and finish up. So next time, that's when we shall dive into the details of this. Is anybody having any question on this? Next time we shall see how you do these ones with 1, because here we don't have, you see that none of them has a 1. So what do we do with that? When you have bar 2 first as a logarithm, how do you find the ant logarithm? So that's what we shall do next week. Next week we shall do that, and we also go to manipulation of logarithms, and also go to application of logarithms. Have a nice week. That's what I've ended today.
Thank you for teaching.
You're welcome.
Thank you.
Thank you for Thank you, teacher.
Thank you.
thank you, teacher.
Thank you, teacher.
Thank you, teacher.
You're welcome. Have a
Put it on
nice
YouTube.
Teacher, will this be on YouTube?
Sorry?
I want my money.
Will this be on your YouTube channel?
You're welcome. You'll find
Just
it on YouTube.